So guys, if you've watched the first video on where I explained Boyle's law, these are some calculations under Boyle's law that we are going to do together. So let's read this question. This question says a certain mass of gas occupies 200 cm cube at 1.0 times 10 raised to the power of 5 Newton per meter square. Calculate its volume when the pressure becomes 2.0 times 10 raised to the power of 5 Newton per meter square at constant temperature. Now, this is at constant temperature. Remember that we said that Boyle's law states that the volume of a given mass of gas is inversely proportional to its pressure, provided that temperature is constant. So when a question comes up like this, and I'm saying that temperature is constant, automatically, I know that that question would be solved with Boyle's gas equation, which is P1 V1 equal to P2 V2, where P is pressure and V is volume. Now, I can't remember if I stated this in my other video. The SI unit of the three most important variables in the calculation of gases. Now, for pressure, our pressure, the SI unit associated with pressures is millimeter mercury, Newton meter square, kilonewton meter square, and atmosphere. While volume, the SI units associated with volume includes cm cube, dm cube, and meter cube. The SI unit associated with temperature include Kelvin and degrees Celsius. All right, so do you get that? Okay, so I'm just going to clean this. If you are following my videos, I'm going to advise you to see it more like your classroom where you come to learn, right? So I'm teaching you systematically, just the same way you would be taught in your classroom. So you could get a pen, get a book, write this so you don't get bored out as well. So yeah, I said the unit of your pressure, the SI unit of pressure is in millimeter mercury, Newton per meter square, kilonewton per meter square, ATM. As we proceed in this video, I'm going to tell you how all of these units came about. Tm cube, dm cube, meter cube, Kelvin, degrees Celsius. So I'm going to clean this right now. If you look at the question, you have 200 cm cube. And the question is asking you to calculate volume. So meaning that I have my first volume as V1 as 200 cm cube. I have my P1 as, what's the SI unit? Newton meter square. So this becomes pressure. So I have P1 as 1.0 times 10 raised to the power of 5 Newton per meter square. Calculate the volume. So this is V2. When the pressure becomes, so P2 is equal to 2.0 times 10 raised to the power of 5 Newton per meter square. Now, I'm just going to put in the values of this into the equation. So, let's clean this and put it beside P1 V1 equal to P2 V2. So, my P1 is 1.0 times 10 raised to the power of 5. My V1 is 200 equal to my P2 is 2.0 times 10 raised to the power of 5. And my V2 is what we are looking for. So this is the unknown. Now I'm going to clean this. And then I'm looking for V2, right? So whenever you're looking for an unknown and you have your equation looking like this, you're going to divide the both parts of the equation. This is the left hand side, this is the right hand side. You're going to divide the both part of the equation with whatever that is holding that unknown. So for this, 2.0 times 10 raised to the power of 5 is holding or is attached to our unknown. I'm going to divide both sides by this. So 2.0 times 10 raised to the power of 5. 2.0 times 10 raised to the power of 5. This. So what I'm going to have here is 1.0 times 10 raised to the power of 5 times 200 all over 2.0 times 10 raised to the power of 5. So this can cancel this. So what I have here is 200 times 1.0. 200 times 1.0 is 200. 200 divided by 2 is 100, so I have 100 cm cube. Now, the reason why I'm using my unit here as cm cube is because if you go over to the question, volume here is in cm cube, hence my V2 would also be in cm cube. But if the volume given to me here is in dm cube, my V2 would also be in dm cube as well. Now, I hope you got this. If you're given this question in JAMB and then you check your options and your options, they are all in dm cube, then you don't have to panic. You simply change cm cube to dm cube. How do you change cm cube to dm cube? By simply dividing by 1000. So 100 cm cube, to change this to dm cube, I'm going to say 100 divided by 1000. This 0 is going to cancel this 0. This 0 is going to cancel this 0. 1 divided by 10 is going to be 0.1. I have 0.1 dm cube. Hope you got that. Now let's look at another question in your Boyle's law, and then we'll go over to Charles' law and see questions in Charles' law. This is going to be the second question we are going to be solving under Boyle's law. This question says a sample of nitrogen occupies a volume of 0.60 dm cube. So I said when you see dm cube or cm cube or meter cube, we know that that value is for volume. Then said at 400 Kelvin and atmospheric pressure. What is atmospheric pressure? Now, I told you that pressure has 4 SI units. It's either it is represented in millimeter mercury, or it is represented in Newton per meter square, or it is represented in kilonewton per meter square, or it is represented in ATM. Now, aside these units, all of these units, they have their values. For example, they have what we call standard pressure. Your standard pressure for millimeter mercury is 70. So standard pressure measured in millimeter mercury is 760. Newton meter square is 1.01 times 10 raised to the power of 5 Newton per meter square. From this value, we got our kilonewton per meter square. How did we do that? Now look at this. There's a 3 here. What happened here is that this decimal point moves 1, 2, 101.3. Now, when you have your figures represented like this in this standard form, what do you do to it? When you reduce the value in whole numbers, what happens to the power? You subtract by the amount of how many times you moved your decimal point. So if this is increasing, this power here should decrease. If this is decreasing, this power here should increase. Now I move this decimal point to here and then to here. I move this decimal point twice. So I'm going to subtract 2 from the power. I'm going to have 10 raised to the power of 3 Newton per meter square. 101.3 times 10 raised to the power of 3 Newton per meter square. Now, this 10 raised to the power of 3 represents 1000, right? And I can call my 1000 kilo, right? K. So, rather than writing 10 raised to the power of 3 here, I'm just going to replace 10 raised to the power of 3 with K, right? Then, this times this, of course, the same thing as joining them together. So this is how we got 101.3 kilonewton per meter square. Now this is the second way, the third way you represent your pressure. This is the pressure, this is its SI unit. Let's clean this. 1.01 times. Now in millimeter mercury we have 760. In Newton per meter square we have 1.01 times 10 raised to the power of 5. Remove this. In kilonewton per meter square, we have 101.3 kilonewton per meter square. Now, finally, for atmosphere, ATM, this means atmospheric pressure. We have 1.0 ATM. So the value of your pressure in atmosphere is 1. The value of your pressure in kilonewton per meter square is 101.3. The value of your pressure in Newton meters per meter square is 1.01 times 10 raised to the power 5. The value of pressure in millimeter mercury is 760. These are our standard pressure, and we're going to be using these values to solve for our gas laws all throughout. So please, what you're going to do for me is that you're going to memorize all of this. It's not hard, just four. Is either your standard pressure is 760 millimeter mercury, or 101 times 10 raised to the power 5 Newton per meter square, or 101.3 kilonewton per meter square, or 1.0 atmosphere. Now, having known this, let's get right into our question again. So let's see. All right, I'm just going to clean this. All right. Now, so the question says a sample of nitrogen occupies a volume. So I'm going to call that volume V1, 0.60 dn cube at 400 Kelvin. All right, so we're going to call this 400 our T1. Okay, and atmospheric pressure. So what's atmospheric pressure? 1.0, right? So P1 is equal to 1.0 atm. That was why I went through all that stress to show you all of that. So that when you hear an atmospheric pressure, you should know it's 1.0 atm. Now, what would be its volume? So we're talking about V2 at 400 Kelvin. So V2 is what we're looking for. T2 is equal to 400 Kelvin. And 507 millimeter mercury. So P2 is equal to 507 millimeter mercury. Now there's a mistake. Now because they've already given you a pressure, and that pressure is in millimeter mercury. So the standard pressure we're going to be using here as an atmospheric pressure is 760. This is because whatever of the values of pressure we use must align to the one that has been given to you in the question. So if my question gave me P2 as atmosphere, I'll use atmosphere. If it was given to me at kilonewton per meter square, I'm going to use that. If it was given to me at Newton per meter square, then I'm going to use the standard pressure for Newton per meter square. So these are my values. Now, if you notice, our T1, our T2, they are the same temperature. What does this mean? It means that this question is in Boyle's equation, because Boyle's equation has to do with constant temperature. So, meaning that the equation I'm going to use for this question is P1 V1 equal to P2 V2. Now, let's solve. What's my P1? 760 times P2 507. What's my P2? All right, let's take this further. 760 times 507. What's my P2? What's my P1? Sorry, V1 is 760. My P2 is 507 times, what's my V2? What I'm looking for. So this is what is holding V2, right? And I said, whenever you're looking for an unknown, you're going to divide the both sides of the equation by whatever that is holding that unknown. So I'm going to divide the both sides of this equation by 507. So 507 is going to rule out 507. So what I have is 760 times 0.60 divided by 507. So let's calculate this. Okay, a minute. All right. So here we are. We have 760 times 0.60 times 1 from this. All right, divided by 507. So we have 0.899. Our volume is in dn cube, so this is going to be in dn cube. All right. Okay, so this is what we have as our V2. Now, one more question in Boyle's law. Let's look at the last question. Hope you're taking note of all of this. All right, so let's look at the next question. The third question we're going to be solving on Boyle's law. So a given quantity of gas occupies a volume of 228 cm cube. And of course, like I told you, cm cube is volume. So my V1 is going to be 228 cm cube. at a pressure of 750 millimeter mercury. So my P1 is equal to 750 millimeter mercury. What would be its volume? V2. What would be V2? So this is what we're looking for at atmospheric pressure. Like I said when we solved the last question, if you're given pressure in millimeter mercury and you are told to calculate at atmospheric pressure, use the value of pressure in millimeter mercury. Now, what's the value of pressure? What is the value of atmospheric pressure in millimeter mercury? 760. So my P2 is equal to 760 millimeter mercury. All right, so now of course, looking at what we have here, we have pressure, we have volume. This is obviously Boyle's law. So using P1, V1 equal to P2, V2, we have that P1 is 750, V1 is 228, P2 is 760, V2 is our variable, what we are looking for. So V2 is equal to 750 times 228 divided by 760. So let's calculate this. 750 times 228 divided by 760. So we have 225. Our volume is in cm cube, right? So this is also going to be in cm cube. Now this is the answer to this question. Now that's pretty simple, right? Really simple. 225 cm cube, and that answers the question. So let's get right into the next thing we have. We've talked about Boyle's law, and we said that Boyle's law states that the volume of a given mass of gas is inversely proportional to its volume, provided that temperature is constant. So let's talk about Charles' law and Charles' equation. Now you remember that Charles' law states that the volume of a given mass of gas is directly proportional to its temperature, provided that pressure is constant. So we're going to remove this proportionality sign, right? And replace it with equal to. Hence, K comes into this equation, and I have my T. So the next thing I want to do is to make K the subject of the formula. So what is holding K? T. I'm going to divide both sides by T. So T would go, K is equal to V over T. Now, when comparing gases at two different volume or two different temperature, this equation becomes V1 over T1 equal to V2 over T2. Charles' law equation. Now, this is pretty about what you need to know about Charles' law. Like I said in the overview of this topic, that when you increase the temperature of a substance, the freedom is going to increase. The disorderliness is going to increase. Hence, it is going to occupy more space. So, volume is the space a gas occupies. So, if I increase the temperature of a substance, let's say a liquid, you boil water, what happens? It changes to steam, and this steam begins to find its way out of your kettle, out of your pot, and what happens? It begins to fill the space and begins to occupy more space than usual. So this is how we arrived that if temperature is increased, the volume would increase. So let's see some questions under the guy called Boyle. By the way, this guy, his full name is actually Jacques Charles. All right, so let's see some questions under Charles' law. First question, we're going to be solving under Charles' law. The question says the volume of a fixed mass of gas measured at atmospheric pressure and 27 degrees Celsius. So it means that we're looking for the volume of the gas because it says it's 3.0. Calculate the volume. So we're looking for the volume of the gas at this temperature and at the same pressure. Now, this says atmospheric pressure, and here we see that the same pressure. Of course, this um, confirms the law, Charles' law, because we say that Charles' law, the volume of a given mass of gas is directly proportional to temperature, provided pressure is constant. All right? So the same pressure means that we are going to use the equation V1 over T1 equal to V2 over T2. So our V1 here is 3.0. So V1 equals to 3.0 dm cubed. T1, remember, whenever you are given your temperature, I told you there are two units of temperature. Is either temperature is measured in degrees Celsius or temperature is measured in Kelvin. And when you are given temperature in degrees Celsius, you convert this to Kelvin by adding 273. So I'm going to add 273 to this. So equal to 27 plus 273. This is going to give me 300 Kelvin. All right. So the next thing I want to do is V2. But they said calculate the volume. So meaning that my V2 is what I'm looking for. Now T2 is 127, still in degrees Celsius. So I say 127 plus 273, which is going to give me 400 Kelvin. If 27 plus 273 will give you 300, of course, adding 100 to it is going to give you 400 Kelvin. Now let's input this value. V1 is 3, T1 is 300, V2, I don't know, T2 is 400. So what's going to be the value of V2? V2 is going to be this multiplied by this divided by this. Now remember that if you multiply this by V2, this is going to be together with the unknown. And what did I say to you? That you're always going to divide through the equation by whatever is holding the unknown. So cross multiply, that's simply what we are saying. 3 times 400. If you multiply this, you're going to have 300 V2. This is already V2. So I'm going to divide both sides by 300. So cancel. V2 is this divides. V2 is equal to 400. Now remember we are told to calculate V2, right? Now come back. V2 here is measured in dm cube. Hence, this is also going to be, sorry, this is wrong. This is 3. 3 times 400 divided by 300. Okay, so 3 here is 1. 3 here is 100. So 400 divided by 100 is 4. So 4 dm cube. Remember that the first value was in dm cube. So, and this is the answer. Okay, so let's see another question under your Charles law. Let's see just one more question and then we're going to move to the next thing under gas law. 35 degrees Celsius is cooled to minus 42 degrees Celsius. This is minus, okay? Calculate the ratio of the initial volume to the final volume at constant pressure. So we have that our P1 is our T1. Degrees Celsius is the unit of temperature. So I'm going to have that my T1 is 35 degrees Celsius. Change this to Kelvin. 5 plus 3 is 8. 3 plus 7 is 10. So we have 308 Kelvin, right? T2 is going to be minus 42 plus 273. Now, this is the same thing as saying 273 minus 42. So 3 minus 2 is 1. 7 minus 4 is 3. And then you have your 2 here. So we have this. Calculate the ratio of the initial volume to the final volume at constant pressure. Now, when you see constant pressure, what comes to your mind? Remember that Charles' law states that the volume of a given mass is inversely proportional. Sorry, the volume of a given mass is directly proportional to its temperature, provided that pressure is constant. So, having known this, they are asking us to look for the ratio of the initial volume to the final volume. Charles' equation has that V1 over T1 equal to V2 over T2. If I cross multiply this, I'm going to have that V1 times T2 equal to V2 times T1. So I'm being asked to look for the ratio of V1 over V2. Now, All I need to do, since I have V1 times T2, I'll call here T2. V2 times T1, I'm going to call here T1. Because if I cross multiply V1 times T2, V2 times T1, I'm going to get the same thing. So I'm going to use this. Rather than using this, I'm going to use this. V1 over V2 equal to T1 over T2. Now, do you get that? Now, having used this, all I need to do is to bring in my T1 and my T2. So my T1 is 308 and my T2 is 231. So what is going to be the ratio? All right, so let's calculate. 0, 1 divided by 231. This is a jam question. And the options are A, all right, so this is a jump question, and we have option A as 1:2, option B as 2:3, option C as 3:4, and option D as 5:6. So 1:2, which is half. 1 divided by 2, it's half. So 308 divided by 231 is 1.3. So this is 0.5, which is not the same as this. This is 2 divided by 3, which is 0.6, not the same as this. This is 3 divided by 4, which is 0.75, does not correspond to this. This is 5 divided by 6, 0.083, does not correspond to this. So from this jump question, the answer is obviously not here because we have 1.3. But I'm thinking if we had exchanged these values, 231 divided by 308, we'll be getting 0.75, which corresponds to this. So probably there should be a mistake in this question, and maybe the question wanted to have said initial at 42 equals to 35. I don't know, I just think. But then, of course, none of these answers are correct. Do you understand that? So, let's get to the other thing we have. Let's get to pressure law. Let's see that.